Solving Logarithmic Equations, Part 2. Our second type of log equation has a log on both sides of the equal sign. So you're going to condense both sides so that that's all you have is one log term on each side of the equal sign. And there are two different ways I have heard this talked about. Essentially, it gives you the same thing. One train of thought says raise both sides from the base of the log, and another train of thought just says set the arguments equal and solve. So I'm going to just show you both, and then after this we will go with the second way. Right? So on this problem we need to condense the log on the right hand side. The left hand side is fine. On the right-hand side, we have the sum of logs, and so that gives us the log of the product. Right, and these are both base 10. So if you go with the first way I said there, and this is the way I was taught, your base here is 10. You can raise both sides from the power of that base. This is the property that we're using here. When a log is raised from a power and the base of that log is the same as this power, the answer to that is just the x. And this is called the argument. And so once we set up like this, this will just equal x plus 4. And this will equal 4x. So that's why either way you're thinking of it is fine, because eventually the arguments are just set equal to each other. And now you solve. This is a nice linear equation. So I'm going to subtract this x from both sides. So 4 equals 3x. Divide by 3. So x equals 4/3. Remember to check with these. Back in the original, you cannot take a log of a negative number or 0. So if I put 4/3 plus 4, that's fine. That is more than 0. Log of 4/3, that's also fine. And this one already has the 4 in there. It does not have a variable. So your answer is 4/3. This problem is similar to the last if you would like to pause the video and try it yourself first. We have a log on both sides of the equal sign. We need to condense on the right hand side, so the left hand side is fine. On this side we have the sum of logs, so that will be the log of the product. And these are both base 10. So we can actually just go ahead and drop the log rather than raising from 10 to the power and then dropping. And it will set the arguments equal to each other. Right, so I have x on both sides. I'm going to subtract this x, which will leave me 10 equals 9x. Divide by 9. So 10/9 equals x. Remember to check. If you plug 10/9 in here, that's okay. That's bigger than 0. 10/9 here is fine, and nothing to plug in there. So your answer is 10/9. For this equation, we do have logs on both sides of the equal sign. We need to condense on the left-hand side. We have a sum of logs, so this will be the log of a product. So the log of x times x minus 2 equals the log of 35. And so we can drop the logs. These are both base 10. We can drop those and set the arguments equal. So we're using that property from before. This one gives us a quadratic equation. Go ahead and multiply out on the left-hand side, and then you're going to subtract your 35 to get a 0. So we have x squared minus 2x, subtract the 35, equals 0. Factor on the left-hand side. It's a trinomial, different signs. Split the x's. 7 and 5 would work, and you want minus 2, so put that sign with the larger one. And then set each one equal to 0 and solve. So if x plus 5 equals 0, x equals negative 5. And if x minus 7 equals 0, x will equal 7. We have to check these in the original, and the negative 5 is going to get thrown out. You cannot take the log of a negative number. So try the 7, log of 7, that's okay. 7 minus 2 is 5, log of 5 is okay. So 7 is going to be our solution. Our next problem uses natural log. It still obeys all the logarithm properties. It's just a logarithm base e. And so this is our property from earlier. This is the same base on this log as the base here, and they will cancel and just leave you the x. Right, so we need just one log on each side. On this side we can combine those, and this is a sum of logs, so it will be the log of the product. And so we could raise these both from e, would cancel this out, and just give us the arguments. So we have x minus 4 times x plus 3 equals x minus 13. So we have to do some algebra on this left-hand side, multiplying two binomials, so we can use the FOIL technique. So we have x squared plus 3x minus 4x, outside and inside gives us minus 1x, minus 12 equals x minus 13. You need to get a 0 on one side, so you want to get rid of these terms. So I'm going to subtract an x. I have minus 1x already. If I subtract another, I'm going to have minus 2x. I'm going to add 13 to make this cancel. Add 13 here, it's going to give me a plus 1. Factor. So, like signs both minus. My only choice here is 1. And so I'm going to have x equals 1. If we plug that in, 1 minus 4 gives us a negative number. We don't have to look any farther. There are no other answers. So this one has no solution.